Alright, this is round 12 of random LeetCode problem, under an hour to started. Okay, you're given an n by n integer matrix grid. Oh wait. Alright, grid where each value, grid ij, represents the elevation at that point. Okay, the rain starts to fall. Time t, the depth of the water everywhere is t. Okay, you can swim from a square to another another four directionally adjacent square. So, like that, right? If only if the elevation of both squares individually are at most t. Wait, what? If the elevation of both squares individually, it's at most t, okay. I'm confused, but okay. You can swim infinite distance in 0 time. Sure, okay. Of course, you must stay within the boundaries of the grid during your swim. Sure. Sure, there's the least time until you can reach the bottom right square. If you start at the top left square, 0, 0. Okay. So, not understanding the depth of the water part, does that mean at time 0, the depth of the water everywhere is 0? The elevation of both squares individually are most t. So the elevation of both squares, so like this number 0 and 2, has to be at most t. So you can only travel to 2 if you're at t, travel to 1 if you're at t. Right. Can I go anywhere else because 4 is actually a decent neighborhood of higher elevation than t0. And the water is 3, you can swim anywhere in the grid, sure. So at time 16, you can go the entire thing. Yeah. Okay. So essentially, you start in the top left corner, find a path to the bottom right such that the maximum value on the path, the maximum individual value on the path, is the minimum of all paths. Right? Okay, so currently I'm thinking DP, right? How do I structure this? Let's think. DP, where the height to get to I comma j would be equal to dpij is equal to elevation necessary to get to I comma j, and then we just return dp of, is this square all the time? Yeah, it's n by n, so n comma n, and dp of I comma j be equal to minimum of any of the 4 directions. So up, down, left, right. For I in range. I'll just define n right here. Is a first one always 0? Each value is unique. Okay. N is less than or equal to 50, which is interesting. Okay. It doesn't say the first one is guaranteed to be 0. So let's assume it's not. Does that change anything? Yeah. Well, it doesn't change the code, but doesn't mean I have to initialize the grid differently. So dp is equal to 0 times n times n. Yep, that should be good. And then we said dp 0, 0 equal to grid 0, 0. For I range n for chain range no, it's still n. dp of I j will be equal to what? Or rather, I feel like I want to do this instead of doing this bottom up like we're doing right now. I think I want to do this top down because you go here, right? For example, 3, 2, and 1. The minimum, you pick the minimum, and you follow that path. Wait, no, that's not true. Because you wouldn't just follow the minimum. It's 16, the one that matters. You define this to be 7. This would be 20. This would be 8. This would be 9. This would be 10, 11, 12, 13, 14, 15, 16, 16, 16, 16, 16, 16, 16. This would be... Okay, wait. No, so let's say I'm defining it this way, right? This would be defined as 0. This, everything else is already negative infinity. It starts... Okay, so it starts at infinity, obviously. So this only way to go would be 1, or would be to come from 0, and the max between these two is 1, so it'd be 1. This would be 2, 3, 4. Then the only way to get this one would be 24. This guy would be 23. This guy could be 24 or 1, or 24 or 23, and it'd be 23. Yeah, that's what I'm thinking. So dpij would be equal to the min between 4 options, right? Would be left, which is dp of I guess I have to worry about if the left exists, but I don't want to think about that for right now. I might make it plus. I might index everything to 1, or move all the indexes by 1, such that I don't have to worry about that in a situation. Anyway, the left one, which would be I is equal to 0, 0, 0, 1, I 0, 0, 1, 0, 2, 0, 3, 0, 4, 0. Yeah. So I minus 1. J. Max, I minus 1J, and grid IJ. Does that make sense? Or is this supposed to be grid, not DP? I think. I'm pretty sure it's supposed to be DP, but if you're moving left, and so you're like right here. You're considering moving left from 14 to 15. Then versus 21, 15, 16, 15. 19, 15. You're going to pick 14. Assuming you already got there. Wait, if you can travel infinite distances, right? Do I have to do this DP solution? Can I just be greedy? If you're traveling infinite distances in 0 time, then as soon as there's a path, I can just travel the whole thing. So essentially, I would just, the best way to do this would be wait on 0, and then as soon as there's a viable path, just zoom through the whole thing. So how can I draw this viable path? Well, somehow go through grid and the minimum way to get to this. See, the reason why is I'm saying the elevation necessary to get to IJ is literally just IJ, assuming you got to any of the squares that before it. So 20 or 7, right, for 6. So it's consider 1 or 24. I feel I'm overcomplicating this, but maybe it's been a while since I've done DP, but it's not stuck in my head right now. Alright, move to here, we need 1. Here. I'm gonna stick with this. I feel like it makes sense. Here's max everything with IJ, so there's no need for this. There we go. This was left up. Let's do right. Let's do down, right? Is that what I'm missing? Yeah. See, the problem with this is it iterates from left to right. So when you're considering 5, that's fine. When you're considering 12, for example, you only consider 24. So you set this to 24. This would be 24 or 13, 24 or 23. This would be 23. Same story, 22, 21. And then you consider 21 or 5, or, well, 5 and 16. 21 or 5, so you pick 5, which would be 16, so you save 16 here. And then you go along the whole thing again. And then 16 would get killed by 20. Because everyone's just going down. Because you can't go right because we're not iterating right. You can pretty easily say we just iterate through it again, but we go backwards. So for example, let's say we iterate through this entire thing, then we iterate through it again, but we go from right to left. Or rather, after the first row, we go right to left. So just consider the same things. And then look for this. I don't know. It doesn't feel like an elegant solution. And given the time I have left, I'm going to try to find an elegant solution. Okay. In a weird way, this reminds me of a graph problem. Because consider these all nodes. This has an arrow here and here. This has an arrow here, 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 etc. Right? All blocks have arrows and plus sign. And we're just trying to sort them topologically until we get this number right here. Since every number is unique. Can you do that? Since I try 0, I can say at point so starting at time I equals whatever is grid 0, 0 is equal to, we'd remove all the nodes that are before time this, right? And if we remove whatever node this is, then we're good. If not, then we keep going. I like that idea. I like a topological sort better. I know this may be a bit of a unusual move because usually I try to solve it immediately, but I feel this problem, it would hurt my pride if I did this n squared solution a little bit. Anyway, how do I make this graph? Well, I can make an adjacent. I know it's of n is less than or equal to 50, so they're gonna have to be up to 2,500. Yeah, I did that right. 2,500 elements. Thus, I can do create a list of size n squared, because each node is unique, and we need an adjacency list. I guess I'm creating a hash map of size n squared, but that doesn't really matter. Alright, create that adjacency list. Save integer at grid 0, 0. I need an incoming edges list. For a topological sort, I need incoming edges, right? Of each one. So I get all the incoming edges. Let's say I make a list of all the incoming edges. Is that not slower? Because I have n squared nodes, each with 4 edges. So if I check those n squared nodes every time, no, I just have to remove. No, I'm not checking n squared nodes. I'm checking the nodes that have, or whatever is in list, I'm removing. So I'm removing everything from time 0 to whatever is in grid 0, 0. Whatever nodes are there, I remove, and then I check if whatever's in NN is removed. If not, then I just gotta check if any of the new ones are removed. Yeah, I think I like that. Anyway, so same code here. But now we're just making a adjacency list. Let's save the initial height. So initial time to grid 0, 0. And then so incoming is equal to a dict, and it's going to be incoming of target time is equal to grid n minus 1 n minus 1, n is up here, so look at that. And target reached be equal to false. And so for all the grids, remove set incoming to all of their nodes that are less than, or that are greater than the target time. Incoming of grid ij is going to be equal to a set of nodes which would be the 4 around it, right? So, for example, for 0, which is where it'd start, its incoming will be equal to none, because it's starting there. So, right? Yeah, anyway. So for the first one, we just leave it as nothing. Because we will just remove that. We need to keep track. Oh, we need to keep track of all the outgoings too, because that's how we remove from topological. So let's say this is a tuple, right? Or let's say this is going to be the first set will be the incoming. Second set will be outgoing. I don't know if I need incoming actually. I keep confusing myself. But anyway, let's say outgoing would be comma I plus 1. I really don't know how I want to save this either. Probably as numbers. Do I really need incoming? Hold up. What am I using incoming edges for? So I follow the outgoing edges. So for the first one, I remove that, and I remove all of its outgoing edges. Every time I remove something, I check if I remove the final node. If not, I keep going while incrementing the time. This will just be a topological sort is also O of n squared, because the grid values are going to be n squared, and we're iterating by t. Unless we're not. Am I iterating by t? Well, I'm removing topological sort, right? So then I remove the outgoing edges. I remove the least one. So I'd remove, let's say for 0, right? It would add C0, I'd see 1 and 24. I'll remove 1. And I'll see 2 and 24, I'll remove 2. See 3 and 24, I'll remove, I'll remove 1. Then I'll see 24, 23, 22, or 24, 23, 2. I'll remove 2. I'll see 3, 24, 22. Then I'll remove 3. Then I'll see 5. I'll see... Does that make sense? So what it seems like to me is just greedily select the next cheapest one is what this topological sort is looking like. Which I guess is what it is, but... Okay, here's what I'm thinking. So you start with 0, right? You have 1 and 24. And then you remove 1, and you insert 2 and 23. You sort it again. You go to heap. Just keep removing until this number has been removed. Once it has, just whatever the max value that you removed is, that's it. Oh my god, I don't know why that took me so long to get to. That's most definitely the answer. I wasted all this time. The cheapest move. Until you have removed available, till you have removed say the target value. So target is equal to grid n minus 1 and then you want this to be a max heap, right? And it's all elevation greater than 0. Yeah, it is. So I can just negate everything. We're gonna go to 0. Yeah, so I can just negate everything and then use a min heap. So then I can say heap q dot min heap, I believe it is. Okay, so I can just say heap equal to this, and then start of the heap would be just grid 0, 0. While removed is equal to false, or I'll say finished. Finished is equal to false. Heap max elevation will be -1. Heap dot heap q dot heap pop heap. So pop that. I need to multiply by 1. This is just a minimum heap, so we're making a max heap, so I'll multiply everything by -1. Wait. You want it to be a min heap because you're removing the minimum value. Yeah, I don't know why. Okay, that's fine. Yeah. So heap pop is equal to heap. Remove or LF is equal to this. Max elevation would be equal to LF because LF is guaranteed to be the max. Well, I guess technically not. There we go. And then heap q dot heap push heap, and we add the adjacent elements, which would be in order. We're gonna go the right, which would be grid I plus 1 j. And then we go this guy, which would be down plus 1. This would be left. minus 1. Right, or, oh. Minus 1. Okay. And of course we only do that if let's make a quick little function actually. Let's just call it def within bounds I comma j if I is less than n and equal to 0 and j is greater than equal to 0 and j is less than n, return true. Else false. Right? Pretty easy. Just because I don't want to deal with writing this out a bunch of times. So within bound let me do I plus 1j. Right. And it has been visited before, so grid plus 1. I can do this because I'll short circuit if it doesn't follow the bounds, so it's fine. J is not equal to float infinity, which it will be. It'll only be float infinity after you pop it, so let's set float grid 0, 0 equal to float infinity. Alright, then we push it, and then we set this guy to float infinity. Yep, so you just gotta do this for all of them. A lot of copy paste code, to be honest. I almost want to change my within bounds function to make this happen. I guess I am on time limit, so I can't be as efficient of a coder as I would like. Speaking of inefficient, this is I j plus 1. This would be I minus 1. Okay. Just gotta do copy paste this guy. This is j plus 1 plus 1 I really don't need these parentheses, but hold up. Is that right? J plus 1, j plus 1, I j plus 1, I j plus 1, I j plus 1, I j plus 1. Nice. This would be I minus 1. Minus 1j, minus 1j, minus 1j, minus 1j. Nice. It's I minus 1, I minus 1, ij minus 1, ij minus 1, ij minus 1, ij minus 1. Nice. Anyway, that's fine. If LF is equal to target, return max elevation. I could make this a while true, but whatever. Yeah, let's see what happens. Oh, right, I didn't tab these. There we go. Right. Don't even move within bounds. I don't remember. Yep, that's why. Wasn't sure what type of language Python was. Let's put it up top here. Keep hitting Command S. All right, let's see it. Oh, right. Oh, I see. You gotta save what elev's last. What the position elev had was, such that you can add its connections. Okay. Elev I comma j. Deconstruct that real quick. Heap will be grid 0 0 comma 0. Right, so the first item would be a list, and the first element is a value, second element is the ij coordinates. That should work. Oh, do I add the ij? Oh, no, I didn't. Okay, I didn't add it here. You cannot unpack a non-interval. Oh. Int object. Oh, wait, right. Is it this? I think it's just that I didn't add this to, I didn't add this whole structure. Ugh, this is annoying me. Okay. Okay, so I made them all a list. And now I have to add the tuple. Which would be I plus 1 comma j. Now for this guy, it would be I comma j plus 1. And this guy would be I minus 1 comma j. This guy would be I comma j minus 1. Should be it. There we go. And let's test. Let me run a case real quick before I do that. I want to see if it would work with just 0. Nice, okay. So I'll submit it. See what happens. Yeah, I can't believe I decided to go DP for that one. For in the middle, that really wasted all my time. Okay, 50 minutes, a little way longer than I thought it would take. Disappointing, to be honest. I gotta get faster at realizing what methodology is best. Stop rushing into the problem. Anyway, there we go. Success.